This is question from Jan'23, question number 10. A student was asked to prove by exhaustion that if n is an integer, then 2n square plus n plus 1 is not divisible by 3. The start of the student's proof is shown in the box below. Consider the case when n is equals to 3k. So there is a working, and in this working we have the answer. This after simplification, 3 bracket 6k square plus k plus 1. So this is not divisible by 3. This is not divisible by 3. So this first part is divisible by 3, but 1 is not divisible by, and there is a sum. So if 1 is divisible by 3 and the other term is not divisible by 3, the whole expression is not divisible by 3. So first, before starting the solution, uh, what is meant by the proof by exhaustion? Proof by exhaustion is the proof that something, means a statement, is true by showing that it is true for each and every case that could possibly be considered. So as we have the start for this proof that n is equals to 3k, so n equals to 3k is integer. So by using different values of k, we can get different multiples of 3, and all those would be the integers. So uh, here, to complete this proof, what we do, as for n equals to 3k, the working is there. We can take a number after this. So as integer, and there's a difference of 1 in the integers. So after 3k, it can be n equals to 3k plus 1. So we will consider next different cases. So consider n is equals to 3k plus 1, or n is equals to 3k plus 2. So the consecutive integers, it can be 3k minus 1. So this or this. So we'll check for these two whether this expression is divisible by 3 or not. So let us use n equals to 3k plus 1 here. 2nk plus n plus 1. 2n square. So I'm using first n is equals to 3k plus 1. It can be or 3k minus 1. So difference of 1. 2n square plus n plus 1. 2 into the value of n, 3k plus 1. So I'm trying a number which is immediately after 3k, 3k plus 1. So for 3k the working is there, and for 3k the students prove that it is not divisible by 3. So to complete this proof, I'm taking a number which is next to 3k plus 3k, which is 3k plus 1. So whole square plus 3k plus 1 plus 1. Let us simplify. 2, 9k square plus 6k, carefully open the brackets, then is plus 3k plus 1 plus 1. Opening the brackets, 18k square, 12k plus 2, 3k plus 2 is coming up. Further simplifying, 18k square plus 15k plus 4. From the first two terms, yes, I can take 3 common. If 3 is common from the first two terms, inside is 6k square plus 5k plus 4. Now here, the in the first we have 3 multiplied by something, so this part is divisible by 3, but 4 is not divisible by 3. So if one is term is divisible by 3, other is not divisible by 3. So you can write a statement here that the whole thing, uh, we started from here. So 2n square uh, plus, so this is not divisible by 3. This is not divisible by 3, or 2n square plus n plus 1 is not divisible by 3. Last case I can take as n is equals to 3k plus 2. It can be 3k minus 1, the number before 3k. So use this in the given expression again. So it is 2 outside 3k plus 2 whole square, 3k plus 2 plus 1, 2, 9k square, 12k4 plus 4, 3k plus 2 plus 1, 3. Further simplification, 18k square plus 24k plus 8 plus 3k plus 3. Next step, 18k square plus 27k plus 11. So this is the simplification. And from the first two terms again, 3 is common. If 3 is common, inside is 9, uh, 6 k square plus 9k plus 11. Now, again, as this 3 is multiplied with a bracket, the whole term is divisible by 3, and 11 is not divisible by 3. So if one term is divisible by 3, the other is not divisible by 3, so the whole thing is not divisible by 3. So I can give you a little explanation. Like if there is 3 and say uh, 18. 3 is divisible by 3 and 18 is divisible by 3 because 18 comes in the table of 3. So what is 3? So both are divisible by 3. So 3 plus 18 is 21. So 21 is divisible by 3. But on the other hand, if there is one 3, the other is say 10. So 3 is divisible by 3, but 10 is not divisible by 3. So when you add, so this was 21, which is divisible by, so here 1 is divisible by 3, the other term is not divisible by 3. Sum is 13, obvious 13 is not divisible by 3. So if both terms are divisible by 3, then the whole expression is divisible by 3. So in the first case, there was 3 multiplied by something. So the first term is divisible by 3, but the second is not divisible by 3. So you can say that the whole thing is not divisible by 3. And last, again we have 3 multiplied by something, so the question was divisible by 3. So here we have divisible by 3 the first term, the second is not divisible by 3, so whole thing is not divisible by 3. So after discussing these cases, because these possible cases, you can discuss more cases. You can take 3k plus 4, you can try 3k minus 2 or 3k minus 1. So but based on these three different cases, one is given by the student here in this box, and the other we just we tried 3k plus 1 and 3k plus 2, and eventually this expression, which is 2n square plus n plus 1, is not divisible by 3. So in the end I can write a statement that hence 2n square plus n plus 1 is not divisible by 3. Is not, so this was just for the explanation. Okay, yes, we have this on. So prove by expression that n is in, if n is integer, if n is this was the, if n is integer, then this expression is not divisible by 3. So first is given by the student, and two more cases are given by us. I tried this value, then I use this value for n. So after based on this basic thing there, because this is the basic idea. So the student tried 3k, I tried 3k plus 1, I tried 3k plus 2, I can try 3k minus 1, because y plus 1 plus 2, because the difference between the integers is always 1. So in this way, we can have this to prove by extraction that 2n square plus n plus 1 is not divisible by 3. Not divisible by 3. This is not divisible by 3.